Welcome friends. Now we are going to discuss MANOVA or multivariate analysis of variance. In case of ANOVA, in case of one-way ANOVA and two-way ANOVA, we have seen in case of one-way ANOVA there we have seen that there was one dependent variable and one independent variable. In case of two-way ANOVA, we have seen that there was one dependent variable and two independent variables. Okay. If it is three-way ANOVA, then there will be one dependent variable and three independent variables. Okay. But here in case of MANOVA, you will have more than one independent variables. Okay. So if suppose if there are two independent variables, then we will say that it is two-way MANOVA. If there are three dependent variables, then we will say it is three-way MANOVA. And if there is one dependent variable, then it is not MANOVA, it will be actually ANOVA. Okay. So here the purpose of MANOVA is to test for significant differences in multivariate mean among more than two multivariate normal samples. So your null hypothesis will be samples come from populations with identical multivariate mean. Samples come from the null hypothesis is samples come from populations with identical multivariate mean. That means the it is the multivariate means, that means the means of the dependent variable, those will be identical or those will be equal. Okay. So what we can do here, now I am going to the next slide. Here you can see that MANOVA can detect patterns between multiple dependent variables. But what does that mean exactly? It sounds complex, but graphs make it easy to understand. So let's work through an example that compares that, where you can understand the MANOVA very easily. Suppose we are studying three different teaching methods for a course. So this variable is our independent variable. That means teaching method is your independent variable. We also have student satisfaction scores and test scores. These variables are our dependent variables, satisfaction scores and test scores. We would like to determine whether the mean scores for satisfaction and tests differ between the three teaching methods. Okay. That means you are comparing the mean of the dependent variables, satisfaction and test score, taking into account these three teaching methods. We want to determine whether the mean scores for satisfaction and tests differ between the three teaching methods. So your null hypothesis will be that the mean scores for satisfaction and tests does not differ, between the three teaching methods, and your alternative hypothesis or research hypothesis would be mean scores for satisfaction and tests differ between the three teaching methods. For the three teaching methods, the mean scores and satisfaction tests will differ. Okay. So here the graph below displays the scores by teaching method. One can chart shows the test scores and the other shows that satisfaction scores. These plots represent how one-way ANOVA tests the data, one dependent variable at a time. So just consider this thing. This is just like one-way ANOVA. Here along x-axis there is independent variable, the teaching method, three different types of teaching methods, and along y-axis you are representing the test score. Similarly, in this graph, along x-axis you are representing the teaching methods. There are three different types of teaching methods, and along y-axis you are considering the satisfaction level of the dependent variable. Now, both of these graphs appear to show that there is no association between teaching method and either test scores or satisfaction scores. Both of these graphs appear to show that there is no association there is no relation between teaching method and either test scores or satisfaction scores. What does it mean? It means the groups seem to be approximately equal. Okay. So what it means actually? It means that it's not like for some of the teaching methods the test score is low, or for some of the teaching method the test score is high. That kind of pattern is not found in this graph. Similarly, here also you can see that they are very much scattered in all the cases, all the three teaching methods. So you cannot say that for suppose first type of teaching method the satisfaction level is low, or for the second type of teaching method the satisfaction level is very high, or for the third type of teaching method the satisfaction is moderate. In that way you cannot say. Why you cannot say like this? Because here it is there is no such specific patterns in both the graphs. So hence it is no surprise that the one-way ANOVA p-values for both test and satisfaction scores are insignificant, 0.923 and 0.254. So if you consider alpha value or the significance level is equal to 0.05, then for this you are getting your p-value is greater than the alpha value 0.923, and for this case also you are getting your p-value is greater than the alpha value 0.254 is greater than 0.05. So hence there is teaching method. So you cannot reject the null hypothesis. That means teaching method does not affect the test score, and the teaching method does not affect the satisfaction level as well. Okay. So simple one-way ANOVA, case closed. The teaching method isn't related to either satisfaction or test scores. But hold on, there is more to this story. What is that story? Now have a look at this scatter plot of test versus satisfaction. You have plotted satisfaction along x-axis and test along y-axis. That means you are considering these two dependent variables. This is the example of a two-way MANOVA. So this graph displays a positive correlation between test scores and satisfaction. You can see the pattern. There is an upward trend. So you can say that there is a positive correlation. Since there is an upward trend, so you can easily interpret that there is a positive correlation between test scores and satisfaction. As student satisfaction increases, test scores tend to increase as well. If the student satisfaction increases, then the test score will also increase. Moreover, for any given satisfaction score, teaching method 3 tends to have higher test score than method 1 and 2. You can see that here teaching method 1 is represented by the blue dots. Teaching method 2 is represented by the brown dots. And the teaching method 3 is represented by the green dots. So for any given satisfaction test score, suppose if your satisfaction score is, for example, 3, then you can see that the lowest satisfaction here, it is 1. The lowest test score is 1. You can see here the blue dot, and above it you can see there are brown dots, and green dots are all above. The green dots are much higher as compared to the blue dots or the brown dots. So the green dots are located on a higher value as compared to the blue dots or the brown dots for a specific satisfaction score. Okay. So you can interpret from this graph that in case of third teaching method for the same satisfaction level, the third teaching method is going to provide the best test score. For same satisfaction level, the third teaching method is going to provide the best test score. Okay. So in other words, students who are equally satisfied with the course tend to have higher scores with method 3. MANOVA can test this pattern statistically to help ensure that it's not present by chance. Okay. So that's why before you will see that in this slide, you will see the last slide, it is provided that when MANOVA provide benefits, use multivariate ANOVA or MANOVA when your dependent variables are correlated. The correlation structure between the dependent variables provides additional information to the model, which gives MANOVA to enhanced capabilities. So it means that if your dependent variables have a strong correlation, only in that case you can consider MANOVA. Okay. So now you can see that MANOVA test statistic is provided. We will not go into very much detail about the MANOVA test statistic because this can be computed very easily using any standard software that are capable to handle these kinds of analysis. So we will look at what kind of methods or tests are performed. Okay. So there are basically 4 different types of tests are performed: Pillai stress, Wilks, lambda, Hotelling lolly trace, and Roy's largest root. Okay, there are not some standard methodology because of the multivariate nature. There is no single or unique solution for extremeness. Okay, so you can use any method, and actually when you will analyze some problem using MANOVA, then this kind of output you will get. Okay. So you can see here that all the tests that I stated, those are performed: Wilks test, Lolly, Hotelling, Pillai's, Roy's. So these are the test statistics which will be automatically generated by your computer. Okay. So here you won't get directly, you won't get any F value from the test statistic. Okay. So here what you will get, the closest F values are given for the test statistic. The closest F values are given for the test statistic. Here for 8.778, 10.275, and 7.297. So you can see here also the significance level. So all these are significant. Okay, all these tests provide you significant result. That means you reject the null hypothesis. Okay, so there is enough evidence of the alternative hypothesis or research hypothesis. Okay, so even though the one-way ANOVA results and graphs seem to indicate that there is nothing of interest, MANOVA produces statistically significant results as signified by the p-values. We can conclude that there is an association between teaching method and the relationship between the dependent variables. Okay. So our null hypothesis was that there is no association between teaching method and the relationship between the dependent variables, but our alternative hypothesis was that there is an association between teaching method and the relationship between the dependent variables. Okay. So in this case, we can, as a summary, we can follow this slide. This is very, in a nutshell, it is very crucial. Okay. So first, you just take a look at the example of this is the example of first I will discuss about the MANOVA that we just stated. So in case of two-way MANOVA, you can see that there are 2 dependent variables. Okay. And what you are testing? You are testing that the association between and x1, this is actually your independent variable, and there are 2 dependent variables, y1 and y2. And your independent variables has 3 levels or 3 methods, M1, M2, M3, just the teaching methods. So you are actually performing, or you are actually testing the association between different teaching methods on the relationship between satisfaction, one dependent variable, and another dependent variable, test score. So this is actually the case of MANOVA. Okay. So now think about one-way ANOVA. One-way ANOVA is only there is one dependent variable and one independent variable. The independent variable will have three levels, M1, M2, M3, three methods. You are testing the association between or the effect of different teaching methods on the satisfaction, say for example the satisfaction score, or if you take it as a test score, then also you can take test score effect that you are considering. Okay. And in case of two-way ANOVA, okay, what you are doing in case of two-way ANOVA, there are two independent variables and one dependent variable. For example, there are one is teaching method M1, M2, M3, three different types of teaching methods, and also there could be the effect of genders, male and female. This is also, you need to consider it as a dependent variable. So you are testing the effect of different teaching methods on the satisfaction level or the test score. You are testing the effect of gender on the dependent variable like test score or the satisfaction level, and also you are considering the effect of the interaction of teaching method and gender on the test score or the satisfaction level. So this is actually you are doing, this is in a nutshell you can say. Here one thing is very interesting to notice, that in case of two-way ANOVA, you are getting here three arrows. You are considering the effect of these variables and also the effect of interaction on the response variable. But here in case of MANOVA, there are not three arrows, there is only one arrow. Okay. You are considering effect of your independent variable on the relationship or on the interaction or relationship between the dependent variables. Okay. So what the other things we could have done, so other arrows could have been like from this direction to this direction, you cannot give arrow because it is considered in case of ANOVA, not in case of MANOVA. And the reverse direction arrow from y1 to x1 or y to x2, that also you cannot consider. Okay, because the dependent the independent variables can affect the dependent variables, but the dependent variables cannot affect the independent variables. So that's why in case of two-way ANOVA, you are getting three hypotheses or three arrows, whereas in case of two-way MANOVA, you will get only one hypothesis, what we have just done right now. Okay. So this is all about MANOVA. Thank you.
So we're going to demonstrate how to conduct a multiple correlation regression in SPSS. We have 20 subjects in this study. They've been measured on forgiveness, relational closeness, and apology. What we'd like to know is the extent to which closeness and apology predict forgiveness. Go to the Analyze menu, Regression, Linear, and as we said, we want to know how these two things predict forgiveness. So we're going to move forgiveness over here, and we'll take each of these and move them into the independence box. We'll click OK. And SPSS provides for us the multiple correlation regression analysis, shows us that the overall correlation between both apology and relational closeness with forgiveness is 0.666. R squared is 0.443. The F value for that R squared, that multiple R squared that is 6.772, and the statistical significance is 0.007. So overall, the two of these things correlate at a significant level with forgiveness. Down here, what we see is that we have a B and a beta for each of the two predictor variables. What this indicates to us is that the closeness variable is not a unique predictor, but the apology variable is a unique predictor.